Hello student, I am Dr. Sanjay Kumar Srivastava, Dev Allied Health Institute, Muradganj, Jaunpur. Now welcome to all of you in this institute, and I am dealing the practicals of clinical pathology, hematology here. So first I am going to dealing the instrument microscope. What is microscope? It is a instrument which measure the object or which visualize the object larger than the normal size. And how many parts? First one is the contents of the microscope. The various components of the microscope can be classified into four systems. First, the support system. Second, the magnification system. Third, the illumination system. Fourth, the adjustment system. I am going in detail for the support system. This consists of the foot, the limb, the revolving nose piece, the stage, the mechanical stage, which gives a slow controlled movement of the object slides, which we have to shown you by the figure and illustrated by the points. The second one is the magnification system. This consists of a system of lenses. The lenses of the microscope are mounted in two groups, one at each end of a long tube, that is the body tube, and the first group of lenses is at the bottom of the tube, just above the preparation under examination and is called the objective. The second group of lenses is at the top of the tube, where the microscopist applies his eye and is called the eyepieces. The objectives. First one is the magnifications. The magnifying power of each objective is shown by a figure engraved on the sleeve of the lenses. The X10 objective magnifies 10 times. The X40 objective magnifies 40 times. And the 100X objective magnifies 100 times. The second is the numerical aperture. The numerical aperture is also engraved on the sleeves next to the magnification. For example, 0.30 on the X10 objective, 0.65 on the 40 objective, 1.30 on the 100 objective. The greater the numerical aperture, the greater the resolving power, the ability to reveal closely adjacent details as separate and distinct. C. Other figure may be marked on the sleeves the recommended length in millimeter of the tube between the objective and the eyepieces, usually 160 millimeter. It is the recommended thickness is millimeter of the cover slip used to cover the object slide, for example 0.17. The screw threads of all objectives are standard, so the objectives in the revolving nose pieces are interchangeable. D. Working distance of an objective. This is the distance between the front lens of the objective and the object slide when the image is in focus. The greater the magnifying power of the objective, the smaller the working distance. 10x objective, the working distance is 5 to 6 millimeter. 40x objective, the working distance is 0.5 to 1.5 millimeter, and 100x objective, the working distance is 0.15 to 0.20 millimeter. E. Resolving power. The greater the resolving power of the objective, the clearer the image and the greater the ability to reveal closely adjacent details as separate and distinct. The maximum resolving power of a good medical laboratory microscope is about 0.25 micrometer. The resolving power of the normal human eye is 0.25 millimeter. The second part, eyepieces. Its magnification is and 4x eyepieces magnifies the image produced by the objective 4 times, and 6x eyepieces magnify the image 6 times, and 10 eyepieces magnifies the image 10 times. If the object is magnified 40 times by the 40x objective, then 6 times by the 6x eyepieces, the total magnification is 6 into 40 is equal to 240 times. To calculate the total magnification of the objective observed, multiply the magnifying power of the objective by that of the eyepieces. Microscopes used in medical laboratory have a magnifying power of between 50 and 1000. So these parts of the microscopes are described here, and the microscope is of two types, or you can say three types: monoocular, binocular and trinocular microscope. So monoocular microscope only one eyepieces have, give better illumination and are recommended for use with 100x oil immersion objective when the sources of light is daylight. And binocular microscope, two eyepieces but only using one objective at a time, are less magnifying for the eyes when long examination have to be made. Electric illumination is, however, essential for the 100x objective. C. The illumination system. The source of light. Electric light should preferably be used since it is easier to adjust. It is provided by a lamp built into the microscope beneath the stage or by an external lamp placed in front of the microscope. Otherwise, daylight can be used. The microscope must never be used and should never be stood in direct sunlight. It should be well illuminated by used in a subdued light. If there is bright sunlight, a bottle or a round flask of clear glass and full of water can be placed in front of the microscope to reduce the intensity of the light. Second part, the mirror. The mirror reflects rays from the light source onto the object. One side has a plane surface, the other a concave surface. The concave side forms a lower power condenser and is not intended to be used if there is already a condenser. Third, the condenser. The condenser brings the rays of light to a common focus on the object to be examined. It is situated between the mirror and the stage. It can be raised maximum illumination and lowered minimum illumination. It must be centered and adjusted correctly. Fourth part, the diaphragm, which is within the condenser, is used to reduce or increase the angle and therefore also the amount of light that passes into the condenser. The wider the diaphragm, the wider and the angle. Consequently, the greater the numerical aperture and the smaller the details seen, but the contrast is correspondingly less. Fifth, filter. In some microscope, colored filters, particularly blue filters, are fitted below the condenser. These can be left in place or removed accordingly to the type of penetration being examined. The adjustment system comprises the coarse adjustment screw. This is the largest screw. It is used first to achieve an approximate focus. Second, the fine adjustment screw. This moves the objective more slowly. It is used to bring the object into perfect focus. Third, the condenser adjustment screw. This is used to raise the condenser for greater illumination or to lower it to reduce the illumination. Fourth, condenser's centering screw. This may be 3 screws placed around the condenser, one in front, one on the left and one on the right. They are used to center the condenser exactly in relation to the objective. Fifth, the iris diaphragm lever. This is a small lever fixed on the condenser. It can be moved to close or open the diaphragm, thus reducing or increasing both the angle and the intensity of the light. Sixth, mechanical stage controls. These are used to move the object slide on the stage. One screw to move it backward and forward, one screw to move it to left or right. Thank you so much.